Okay, welcome everyone. So this is CS 685, 785 Foundations of Data Science. So this is like if you are doing data science, this is like the first course you are going to take. I know that also a lot of students also take deep learning. I think they are not conflicting with each other. But in data science, basically we'll teach you basic stuff on like how to use the data science libraries in Python language mainly. Okay, and besides that, I assume you already are aware of the syllabus. We also have a book which is from Collab on more theoretical aspects of foundations of data science. Okay, so for that actually we will only cover two chapters which are the most important. Okay, so SVD and streaming algorithms. Okay, streaming and sketching. The others are too theoretical. We taught that maybe in the first two times that I teach this course, but I think that occupies a lot of time to explain those theoretical foundations. And so if you're interested in these other chapters, feel free to do so. Okay. So just want to make sure, can you guys see my, see the Canvas page that I shared in a browser? Okay, the chat. Okay, thank you. Yeah, here's our Canvas page for the course website. Okay, so let me briefly go through what we have here. So I am the instructor, Yan. You can also call me Daniel. If you have any question, you can send me email in this email address. Okay, our class Zoom link will be this link. Okay, so the meeting ID actually is this, right? So 976, etc. Okay, to 772. Okay, and if you use that and you type the password, you can also connect. Okay, so we have two TAs. Latif is here right now. He will be having office hours on Monday, 9 to 10 a.m. And if you have any questions regarding this course or assignments, but we will not give you the answers directly. Right? So if you have any questions related to like the knowledge points that you don't understand well, you can go to the Zoom link here to talk to Latif. Okay, he will be helping you. We also have another TA, Shapita. She has an office hour on Wednesday. Okay, 1 to 2:30 p.m. Right, and if you need to make an appointment with me, you're welcome to do so. And just send me email. Okay, we will schedule a Zoom meeting where you can ask your questions. And unfortunately, Pepita has another course that conflicts with the time here. So I think she will send an announcement, introduce herself to all the students. Okay, so stay tuned. And Latif is now in the Zoom. So I will right now give the stage to Latif to introduce himself so that you know the TA better and you know who and when to ask questions to the TA. Thank you. So Latif, can you briefly introduce yourself?
Sure. This is Latif Amudefer. You can call me Latif. And I am a PhD student. This is my second year as a PhD student here at the Department of Computer Science. And I'm under the supervision of Dr. Yan. And if you have any question related to the course that I can help with, especially the programming questions, please come to my office hours on Monday from 9 to 10. Thank you.
Okay, thank you, Latif. Yeah, if you want to leave, you are free to go. Okay, no worries. And I see Frank Wu raised the hand, right? So Frank, do you have any questions?
No, that's biased. I'm sorry.
Oh, it's okay. Yeah. So because we have a lot of students, if you have questions, if you don't have questions, you mute yourself because otherwise there will be a lot of like background noise. But if you have any questions, just mute yourself and ask. Okay. So because it takes time to find the hands. There's too many students, right? So I need to scroll down and find the hand. Okay. All right. So yeah, let's begin. So let me briefly go over what will be required in this course. Okay, so the workload is like this. So we will have 2 written assignments, each at 10%. We'll have 4 mini projects. Okay, so each also 10%. And we will also have like this attendance, 10% of the attendance. And we also have a final project. So this is an important project because it occupies 30%. So you can see that we have no exams. Okay, so it's placed by projects. So this is really a hands-on course because for data science, when you find jobs, you really work on projects, right, and help the boss finish some data analytic tasks, right? Not really just answer the exam questions. But we do have 20% of written assignments. Okay, so these are not timed. You will give 1 to 2 weeks to finish. Okay, but we do require you to also answer some like a paper-based question. Okay, so you're welcome to type your solution using maybe LaTeX or using Word, or you want to handwrite, do handwritten stuff, and make sure your handwriting is clear to the TA. Okay, so you can use pencil or pen and then take a photo, right? Or you can scan it and upload. So all the course will be, we will be submitting using Canvas. Okay, so the assignments, you will be getting the files downloaded from the assignments when we announce it, and you will also be getting the other course links. I will send an announcement to you guys. Okay, and in assignments, we will enable file upload because most of them are projects, right? So it's just finish what we required and upload, and we will check them. Okay, so for the final project, we right now we haven't decided the topic yet. It can be open, but more likely it will be a designated project. Let's say, these days, there are a lot of data science models that are in deep learning. So we probably will work on a particular project for object segmentation. So you want to segment some like cells from a background. Okay, so for that, there may be 5 to 10 models that we can try out, and we will release the data to you guys, and we may involve you guys in a annotation to prepare the data so that these data will be unique. So the reason we are considering doing this is because in prior courses, there's some complaints that students will use the projects across different courses, right? So we want to prepare a unique data set so that it's not reused in other courses, at least for this course. Okay, so that will avoid that concern. And okay, so here again, just so this is Latif's office hour and the Zoom link. Okay, this is the other TA, Shopita office hour and the Zoom link. Okay, this is our class link. Okay, this textbook is more on theoretical stuff, and we will cover 2 chapters. Okay, so I think these authors are very renowned, like John Hopcroft is a Turing Award winner, but this is 2 theoretical computer science. Okay, so we will skip a lot of it. What we will really go over, one of them is, let me see, is algorithm for massive data problems like sketching, streaming, sampling, which means if you have tons of online data, how to answer queries without storing them, right? You have a sketch, right? So then you can answer with good precision, for example. Okay. And another topic I think maybe earlier is let me see. Yeah, it's a singular value decomposition. Okay, so this may not be that this is a lot more like PCA and PCA the application of SVD. Okay, but this is actually a foundation for many matrix, even tensor-based problems. Okay, so understanding this is very important for understanding those more advanced stuff. So we specifically select chapter 3 and also chapter 6. Okay, the others, if you have interest, you can look at them, but they are quite theoretical, so you need to get prepared if you want. Okay, so so these are the syllabus, and our department has a requirement. If you let's go through the syllabus briefly. Okay, I think this may be a better idea. So let me just download it. Okay, so this textbook is fully online, so you don't have to buy it. Okay, so we will release all the documents that will be required, and you just stay tuned on the cameras, and you will get everything you need. Okay, so the topics, we have several topics. Okay, so one is the data science and machine learning tools and libraries, which will be covered from this class on. Okay, so this is very important, right? So if you talk about data science, it's really, these days people are using Python and R, right? So we will touch upon important libraries that we'll be using, especially in Python, okay? And then if you want to work on advanced stuff, maybe you need to go to deep learning, the natural language processing stuff, okay? So we will also look at, like computer vision stuff. Maybe the final project will be a little bit computer vision, okay? This may overlap a little bit with deep learning, but we'll go much faster because we don't really dive into the details of the models. Okay, so what we care about is how you can utilize those data science libraries to finish the real project. Okay, so how to find these tool packages and how to prepare input and apply them into the applications. Okay, and we will have some chapters on big data security and privacy. This will actually go first because there's a lot of hands-on projects. Okay, so maybe the first 2 or 3 topics will be on big data security. Okay, and then we will have streaming algorithms and the singularity decomposition that we just go over in the textbook. Okay, so let me see. So the final project, actually we have the final exam time, right? So, but if the final exam will be a presentation, okay, for any, so the project can be finished by groups, okay? And I think a group of no more than 3 or 4 students, yeah, no more than 4 students, that's fine. Okay, previous years it's 3, but maximum. And so if your group has 1 PhD student, okay, so you need to present. Okay, all of them are like master students, then you can skip this presentation. You are welcome to join. Sorry, what's happening? Yeah. So this time is obtained from this schedule. Okay, so this time is the final exam time, and let's say you have 3 or 4 students, and at least one of them is a PhD student. Then you need to do the presentation. Okay. And let me see. Okay, so there's academic honesty, right? So don't do plagiarism. This is a hands-on project, right? So I think you can complete it on your own and try. It's not timed in some sense, right? So take your time and understand stuff. And if you have any difficulty, you can contact Latif. You can have some Hita, and you can come to help you. Okay, don't plagiarism there will be consequence. Okay, so there's a 3 strides you're out, penalty procedure required by the department. Okay, so the first time you violate, you will get 0 mark for this particular assignment or this particular exam you treat. Okay, the second violation will cause a cost to fail. Okay, the third violation, the department may report to the UAB level. Okay, so you don't want that to happen. Okay, so for attendance, we will take attendance using Canvas. Okay, so basically what we will do is we will use this tool. Okay, so I don't think we will call everyone's name most of the classes. Okay, but we will sample maybe 20% of the students, right? So and we will call the names, and you can also see your name because it's a remote, attendance. Right? So you can see clearly these names, and this is a master student list. There's also a PhD student list. So, there's only 1 PhD student. In that case, I don't know whether the presentation makes sense, but we will see. Okay, so maybe we will do some bonus points for the presentation. Okay, so maybe because of pandemic, we don't have new PhD students coming. Especially a lot of them are from international. Okay, so let's continue. And yeah, so the other stuff I will leave you to check. Okay, so let me see. There's there are 2 messages right now. Okay. And so for the marking scheme, right? So I think we have the marking scheme. Okay, so previously we only require 85, but the department has a rule, right? So they have a reference score since the last semester, and it requires that over 90 you will be A. Okay, otherwise you will be like B, C. But the prior students, most of them actually get very good results. Okay, so as long as you follow the course, because we don't have the timed exams, right? So you will be in good shape, and you will also learn stuff that will be important. Okay, so in data science. Okay. Yeah, that's pretty much what I want to say about this course, and also about the how we will proceed. Any questions? If you have any questions, you feel free to unmute yourself and ask. Okay. All right, so yeah, another thing I want to advertise a bit before we start this course is that I know that most of the students are master students, right? So in the department, we have the direct reading course where you can select a topic and write an abstract and send to Dr. Zhang, and then working on a particular research, right? So if you have interest in working on research topics, you can let me know. Okay, so but we need to see whether you are ready, and because if you are not ready, you need to take more courses before doing that, right? So, and there's also a thesis track. If you think you are very strong, you can do thesis with me also. Okay, so and if you want to know more about my background, you can also Google my name. Okay, so I think you will go to department. This is the cast page, right? So you can go to personal page. And so these days I do a lot of research in deep learning. So if you are interested in deep learning stuff, right? So this is graph mining. So there's a lot of neural network stuff. If you are interested in doing deep learning, this is actually a very quick topic that you can maybe publish a paper or get involved in some research projects. Okay, we have a lot of needs of that. Okay, so if you are interested, you can select a direct reading course, and we can discuss a particular project and then explore a little deeper into that. So because this is the results that you have access to, maybe you want to fully utilize. Okay, so there are a lot of topics in this area, like computer vision and natural languages and medical imaging. Right? So a lot of other like reinforced learning. Right? So a lot of stuff that you can explore in data science, especially deep learning. And another thing that I'm looking at is that, yeah, maybe I talk about it later after we finish the first slide. Just let me Yeah, so I think I have a slide for the course overview. So I will quickly go through them. Okay, so everyone can see the slide? Yeah, if anyone
Yes,
can.
sir.
Okay, thank you. All right, so here are the course overview. Okay, so we have deep learning, data science. Right? Data science is really broad. Okay, so it's like a basic foundation. Right? So we have the scattering algorithms, like graph mining, we have like engineering projects like transportation, etc. Okay, and even Hadoop Spark, which is in big data domain. Right, so we have data science. Okay, right? Because if you remember, previous fancy word is called big data. Right, we have 5 V's. Right, one of them is value, which is really the mining part. Okay, we also have like volume, velocity, etc. Okay, so and I think there's a variety. Right, so one is related to security, another is more related to data integration. So like everyone want a piece in big data, right? Now we are more in data science, and in data science, actually a core part is machine learning. Okay, so and one important thing about machine learning, you need to know different kind of models, but knowing them is not sufficient, right? So you need to know what are the libraries where you can call this model. Okay, so we have a bunch of machine learning libraries, and a significant portion of this course are lying in data science and the basic libraries in data science industry. Okay, and there's also advanced topic like in deep learning. Okay, so for that you might need to learn some deep learning framework and understand the deep learning basic modules. Okay, so different kind of neural network modules in order to proceed with this kind of research. Okay, if you have interest after taking this course and maybe also some other related data science course, and you can contact me and zoom in a particular direction, deep learning, and we can explore. All right, so here are the topics that we will be covering. Okay, so sorry, I think this is the wrong word. Okay, so let me adjust a little bit. So here we will be covering these topics. Okay, so one is data science and machine learning tools and libraries. Right, so you need to get hands-on. Okay, and one important thing you need to know is that, get familiar with those libraries or not. It's a game changer. Okay, so for example, if you maybe most of you have learned let's say decision tree, right, data mining model. Okay, but if you don't know, like say scikit-learn, right? So there's scikit-learn. Then probably you are using Weka or some other decision tree modules that are a lot more complicated, right? So but if you use scikit-learn, it's probably just 3 lines of code. Okay, let me see whether we have an example. So there's a library here, right, called so basically what we need to do is just, hey, I want to, from scikit-learn, it's a Python library. Okay, I import tree, okay? And then I load the data here, and I create a model called the decision tree, right? This is classifier, okay? And then I fit this training, okay, using the data. After training, I can see what the tree is looking like, and I can this is printing the tree, and then I can also do something like do the prediction. Okay, so basically these days data science is making the barrier of learning very low. Okay, so you can just have the best libraries already integrated into Python, and you can just use them. Okay, so so your efficiency, if you are familiar with those libraries, could be maybe 10 times or even many more times faster than people don't know. Okay. Yeah. All right, so with those libraries, maybe we'll also cover some like deep learning tasks, like in computer vision, like for image segmentation that we are planning. We will see whether we want to go that direction. Okay. So another is scattering and streaming algorithms, right? So if you have data keep coming, right, you cannot store all the data on your machine, right? Your disk is just have no sufficient space. Okay, so how to maintain a so-called sketch, right? So that can still answer a lot of queries, even though you don't keep all the data. Okay, so you just see the data, you update your sketch a little bit each time. Okay. Another example is big data security, and we will unfold this into 3 different topics, but 2 really about deep learning and security. And the third one is more about data privacy. Okay. And SVD and the transport planning, and we will see whether we want to go to the transport planning. Okay, so maybe we will replace with image segmentation. Okay, so yeah. I don't know why I keep seeing the chat having student typing yes to me, like even 20 minutes later. So, yeah, okay. So the distribution of the assessment tasks will be attendance, 10%. Okay, so you can ask for leaves before the class. Okay, I know some students have to work full time, but if that is the case, you need to let me know. Okay, so and ask for leave before the class. Okay. If you once the class begins, if you ask for leave, it will not be counted. It's explicitly mentioned in the syllabus. Okay, you can check a look at the syllabus we showed earlier. Okay, and you are allowed to miss 2 courses unless with special permission, right? So like if you have you're ill, right? So you're sick, and then that can be counted. Okay, so and yeah, so we have 4 mini projects, and we also have 2 written assignments. Each is usually the deadline will be within 1 week, but we can do extension to 2 weeks. Okay. Any questions? But the nice thing is they are not timed, so you can you can have less tension. Right? So you have the whole week to complete it. Right? So don't start at the very last day. Okay, that will definitely cause late penalty. Okay, and so you don't have the timed exams in this code. Okay.
Wow. No exams. Are they fast?
Hello? Yeah, I have to mute. Okay, so let's continue. Yeah, so these are the marking scheme. If you are larger than or equal to 90 points in the final grade, you are A. Okay, 8A is B. Okay, 6A is C, and D is 50. Okay, so this is kind of standardized by the department since last semester. And this is 3 strikes you are out that we described earlier. Okay. And we will be using Anaconda. So you don't have to use Anaconda. Okay, so we'll be using Jupyter Notebook a lot. Okay, so I'm not sure whether you guys are familiar with Python. There's 2 versions of Python. Right? So Python version 2 and Python version 3. Okay, so we have Python 2 and we also have Python 3. Okay. So the trouble is that they are not backward compatible. Right? Like if you run forward compatible is not possible, right? So if there's new features in Python 3, if you run Python 3 code on Python 2, right, definitely will not run. But usually, like in Microsoft, they care a lot about backward compatibility, right? So, but if you have a Python 3 code and you have a Python 2 code, oftentimes you cannot run in Python 3 also. So both directions are kind of not straight, right? So not straightforward. You have to make some changes to make Python 2 code even run on Python 3. Okay. So
can we use Anaconda?
Yeah, you can use Anaconda. That's why we are talking about Anaconda. So
Miniconda.
Miniconda. Yeah, you can use whatever you like. Basically,
okay.
Yeah. So here is just a way that we are telling you how to install stuff. Right? So if you use a different environment, it's your own choice. Okay, so you feel free to do so. Okay, so what is Anaconda? Anaconda is a virtual environment. So for example, you usually install all your software in operating system. Right? So for example, you install something like Python, right? You install something like a GCC, which is a super compiler, and some other stuff. Right? So a different kind of package. Okay, and on top of Python, you have a lot of libraries, packages on top of Python. Right? So this may be Numpy, and we will see those stuff later. Maybe scikit-learn, pandas, maybe keras, etc. Okay. So the trouble thing is that the Python has 2.0 and 3.0. Okay, and they are not compatible, right? So if you cannot install both in the operating system. Okay. So one way you can stick to Python 3.0 and then you install everything on top in Python 3.0. Right. If you do that, you really don't need Anaconda. Okay. But here we are starting from Anaconda because we are saying this. Okay? So you can start with your operating system, but you can enter a so-called virtual environment. Right? So say, hey, I want to enter this virtual environment, and by that time my first Python is 2. Okay. If I enter this virtual environment, my Python is 3. Okay. So then there's no conflict. Okay. Even in operating system, I think you can use Python or Python 3 to differentiate these two. But then there's a lot of complications on package, which one is why to which one, right? So using Anaconda can save this trouble. Okay, so that's why we recommend you to use Anaconda. So this is virtual environment management. Okay, so you can download it from here. If you click, it will go to the download page for your operating system. It will detect your operating system. Okay, for example, my current machine is Mac. So if you click here, and you will see, I think it's, let me see. So it seems that they're downloading is changed. Anaconda. I think it's in individual editions, and you can download. Okay, if you click, maybe now you need to click this, and then you need to choose your own operating system. Okay, in the old days, they will just point you here. Okay, now you need to click, okay, and you choose your operating system. Right, so Linux, Windows, or Mac. Okay, then you can download it. And so this is really the Anaconda has a free Python distribution, and when installed, you will also have a lot of other stuff, other packages, and even like the Jupyter Notebook installed on top. Okay, it's an easy way to handle your package dependencies, right? So it basically installs a bunch of passive packages that are compatible into your environment. Okay, all you need to do is install the environment, create the environment, install the environment, and then enter the environment and use it. And when you want to switch to another Python version, for example, you can access the environment and the other environment. Okay. Any questions? So we have been testing that our projects work with Python 3.6, right? So maybe now it's a 3.7 or even later. Okay, so you may decide, but there may be some compatibility issues. Okay, so in any case, try to download the Python 3 version. Okay, don't download Python 2. For example, if you come here and you download, so let's try. So for example, I think, oh, this is Python 3.8 already. So you can download this directly, and there may be archive version you can download to use older versions. That's also fine. Okay, so now it's 3.8. It seems that they retired Python 2. I think Python 2 is no longer in maintenance. Previously, they have 2 versions. Okay. So the Anaconda virtual environment, how to use it, right? So create a virtual environment for this course, right? So for example, you want to create a virtual environment called conda create, and -n is name, and for this course, right, you can use any name you like. Okay, you say I want to install with Python 3.6, or you want a later version of 3.8. That's also fine. Okay, set Anaconda, and this will install a lot of packages rather than to Python 3. Okay, and so you have a lot of packages there already, and maybe even I'm not sure, maybe pandas, those kind of things are already installed, and also so Jupyter Notebook we will see later is also there. Okay, so you don't need to install the software itself. But this thing will take some time to set up your environment. And once this is set up, right, so you can say source activate. Okay, so this is only in Mac or Linux. Okay, in Windows, I think that's another command. Maybe conda activate or something. Okay, so you need to Google a little bit. This is only for Mac or Linux. Okay, so this is saying, hey, I want to activate this environment. Basically, you're entering this environment, right? And if you want to access the environment, you say source deactivate, you will access it. Okay. And if you are just using, conda to install like this, you need to, right, when you want to do your assignment, right? Because in the operating system, you don't have those software, right? Like a Jupyter Notebook. You need to source it, enter this environment, and then create a Jupyter Notebook server. Okay. And after you use it, you may want to deactivate and unload the modules. Okay. So Jupyter Notebook is also called IPython Notebook in old days. So the reason is that I think they now support a lot of other things. Right? So for example, there's no reason you don't want to support MATLAB or R, those languages in Notebook. Right? So now it's called a Jupyter Notebook. Okay? It can support all kinds of stuff. And besides the Python code, you will also sometimes see so-called magic code, right? So those JavaScript code to manipulate on the, the cells, the visual constructs on the page, because JavaScript is a web page maneuver, right? So you can move things and add a table, etc. Okay, by JavaScript. There's also, I think, the shell command, right? So like the console command. Okay, you use a exclamation mark, then you will be able to do that. Okay, we will see these things later. Okay, so these are the tools for most of our programming assignment. Okay, and it will let you write and execute Python code in your web browser, and it's easy to tinker code and execute bits and pieces. Right? So we will understand it how it works right now, and then I will do a simple demo to show you how it really works. Okay, so firstly, so if you already installed the virtual environment, you really don't need to go to the Jupyter Notebook, the Jupyter project, download their software, okay, because it's already there. But if you want not to use conda, then you need to do this yourself. So you need to install and then know how to do these things. You need to pipe install these things. Okay. And if you use conda, then just enter the conda environment, and then the software already installed earlier when you create it right? So you just need to say, hey, Jupyter notebook, okay? This starts a server. So right now, what we are doing here, yeah, I see a question asking whether one Python version is enough. Yes, you just need a one Python version, okay? That's the purpose we use Python 3, okay? So Python 2 is outdated, we are no longer using, okay? It's a legacy language. And where is my mouse? Okay, I get control back. Okay, so basically what we are doing is this, right? So you will create a console and then you will do this, then you enter the environment where you have the library like Jupyter installed. And then you type this command here. It will create a server running on the back end of your machine, maybe your laptop, okay? And then you can go to your browser, okay? And because the server is already there, then you can type the URL, it will connect to the server. And the server, then you can work on so-called Jupyter notebooks. Okay, so these notebooks are, we'll see them later. Okay, so then you can basically work with them. Right, so the Jupyter notebook really designed as a server browser architecture, which means you can actually have your Jupyter notebook running on a cluster. Right? So one particular example is Google Collab. Right? So I would say that you can also go directly with Google Collab. Okay, so Google Collab will allow you to. I'm not sure what is this, but let's see. Right, so also run Jupyter Notebook file. Okay, so I would encourage you to check out some YouTube videos introducing what is Google Collab. Okay, so this thing will allow you, GPU actually. Right, so NVIDIA, you can even use Tesla T4 GPUs, and it will, once you start to running this notebook file, this IPyNB, this Jupyter notebook file, it will allocate a virtual machine for you. Okay, right now it's connected. So this thing is pretty easy to use. So if you are lazy, you don't want to install everything on your own computer, you can use Jupyter notebook. But it will be connecting to, you can even directly download the stuff from GitHub. Right? So it will be, but this is a Linux command, right? So you do need a exclamation mark. Otherwise, it's mostly kind of like Python code, right? Using the Python, Python function. Okay, so these are the things you can show images. This is all Python code. Okay, if you want to use your console command, you have to use exclamation. Okay, and the nice thing about it is that you can still download. Right, so you can play with it and download your Jupyter to your local. Okay, and the files are actually saved in Google Drive, and you can even connect with Google Drive to see what are the data down there and how to work with these files. Okay, so this is like a free cloud service that you can use. So if you want to skip Jupyter Notebook installation on your own computer, that's also fine. Google Colab provides a compatible server. Okay. If you are using your local server, then you need to go to localhost. Right? So this link. Usually, after you create this link will be automatically pop out from the browser. Okay, so then you can directly use it. Otherwise, you can type this. You can still connect to the server. Okay. And let me see the time. Yeah, so we will take a break in at 6 p.m. Okay, so let's continue. So once you do this, right, usually the browser will pop up, okay, with this UI, and you will see the Jupyter Notebook. So a lot of students are confused where they are, how this is, where this is, right? So basically, in your console, right, you can go to any location, CD, right, change the directory, and the current position, maybe some position in your file structure. Okay? Like this is your home, and this is your name, and then you create a assignment folder, right? And if you type Jupyter Notebook here, you will see the whole everything down this folder as this root folder. Okay, so you can put it anywhere you like, as long as you start your Jupyter Notebook from there. You cannot go above it. You can go any layer below it. This is a file, it's like a file explorer. Okay, so yeah, that's it. And another important thing is that this file is a JSON file. Okay, so this is has particular format. Okay, so only if you have a Jupyter Notebook server running at the backend, it knows how to interpret into the browser. Okay, if you double click, you cannot see. It's just a JSON file. This is a notebook file. If you click through here, right? So this IPython notebook file is made of a bunch of cells. Okay, so cells are like these cells. Okay, so each cell can contain some Python code. But here it's like x equal to 1 plus 1, then x equal to 2. Okay, but you run it. So one way of running it is using this arrow here. Okay, but usually we will just do shift and enter. If you look at the keyboard, shift and enter are just back to back. Right? So enter or return is at the top, and the shift is at the right below it. Okay, especially for laptop, I think. Yeah. So this is the output of the cell. Okay, it will be displayed beneath the cell. So basically, so this is a input for your code. Okay, where you can put your code. Right, and when this is the running order. This is the first cell you run. You run the second cell here, or you can run second cell here and come back to run the third cell. So it's not recommended, but you can run in different orders. Okay, and there will be usually an output space, which is here. This is usually what you show on the panel, but in your console. Right? But here, it will connect to the output cell. And if the output cell can be super long, right? So for example, if you run something that will print 2,000 lines, right? So then it will be super long. And if you want to show the entire thing, then it will be too long. Right? So there's actually a hidden button here. If you click, it will have a fixed size, and you will have a scroll bar. You can scroll down. Okay. If you click again, then it will show everything in this file. Okay. So you don't have to scroll down. Right now, it's just one number, so it's not so severe. And another thing that I think this is relevant to Python. So Python is something like if you create something, you don't need to say its type, like int or something. Okay, it can be any type. Right? So this time it's integer 2. Right? Next time you can give a string. Okay, and this thing is actually holding in the global memory. Okay, so it's a global variable, unless you call delete x, DELX. Right? Otherwise, it's always in the memory. So the next cell can access it. Right? So because it's now 2, and you times 2, y becomes 4. Okay, if you run it, it will be 4. Any questions? And so far, these cells are all type code. Okay, so we have the code type. And there's other types. One important is like the markdown. It's like the note, right? So you can take a note. That's why it's called a notebook, right? So you can have code. You can also have the, you can also write some note. Okay.
Is there any reason to use Jupyter over just like keeping random Python files? Or is it easier to keep track of?
Yeah, it's easier to keep handle, right? You can write any node down there, and you can see the entire execution workflow. So you can revise, right? So in Python file, you need to double click and revise. Right? So you can first try everything in Jupyter Notebook. When it's stabilized, you copy and paste to the .py file. So
I got you. Cool. Thanks.
Yeah, here's an example. For example, if you do, what's this? Yeah, so again, so it's recommended you run from the first cell down, okay, in sequential. But it says the software itself, so the software itself doesn't prevent you from doing that. Right? So here it's like you are first running the second cell, okay? But if you run the second cell, then X is not defined yet, okay? Right? So in that case, it will give you an error, right? So then you know what's happening and you can do some fix. Okay, so the Jupyter Notebook, there are two benefits. One is you can immediately run and see what's the error and then do some fix, okay? Right. And another thing is that you can keep some note, and you can even keep the error, right? You can add another cell by plus button, and they can do something, right? You can keep track of the previous error here, okay? Let's see. And finally, usually it will auto-save stuff, right? But just to be safe, you want to maybe save the checkpoint yourself. Click, okay? Whenever you modify, save your changes. Sometimes it's saved every maybe 1 minute, right? So in between that, things will be lost. Okay? So I think there's also a button here that you can see. So depending on what you want to use. But I will demo it, by the way. So right now we just finish this slide, and then we will demo by going through some files. Okay, so and this is what we've talked about, right? We have Python 2 and Python 3. By that time, we teach maybe even last year, Python 2 is still in maintenance. This year, I think Python 2 is out of the state. Okay, so Python no longer maintains Python 2. Okay, so it's really not even on the Anaconda website. So it's totally dumped in some sense. Okay, but if you have Python 2 code, you should still have Python 2, interpreter to run. Right? So maybe a good idea is convert them into Python 3 versions, though it's not easy. There's a lot of details here. And you can check a Python version by this command, okay, Python -- version in your console window. Okay. So here we'll give you assignment 1. We'll go through it as an illustration. So don't worry. Okay, so we'll briefly explain what they are. So basically, this familiarizes you with Python and a library on Python called Numpy. Okay, so let me briefly introduce what it is. So maybe introduce a big data science domain. Okay, language domain. Okay, so maybe some of you studied Python. But Python itself is just a language. Okay, so after you study Python, if you don't know these libraries, it's useless. Okay, I will explain why in this lecture. Okay, so actually Python is known to be very slow to execute. Right? So, but those libraries are very fast because they are not, since they are C native, okay, native packages. Okay, so we'll go to these details later. Okay, on top of it, you have the linear algebra kind of library, like numerical computing library called Numpy. Okay, and then everything on top is built on Numpy. Okay, so for example, if you look at machine learning library, right, scikit-learn, it's on Numpy. Okay, right. So and usually you also need a so-called pandas, right? So pandas to load the data. Okay, and then using scikit-learn to do some machine learning. Okay, and if you look at like TensorFlow or even other models, okay, it's even built on top. Okay, so maybe Keras. Okay. So Numpy is really the foundation of everything, right? Because you are doing numerical computing. Okay, so we will go through these two. Okay, there's a lot of other things like pyplot, etc. Right? So these days there's no point to using any other tools. Right? So in the old days, people plot things. They use GNU plot. Right? So now we have pyplot. Why go with GNU plot? Just open the Jupyter notebook. Plot pyplot until you feel satisfied, and then save it as a save image, save figure as a PDF in vector format or EPS. Right? So then you can import into the paper. Okay? So basically, the Python library is kind of outdated a lot of other stuff. Right? And if you look at the Linux, so Linux shell previously was very powerful, and if you run some batch code, you need to run Linux shell. Right? So now you just run Python script, okay? And you can have Python system, your command, and this will run a Linux shell, okay? So that means that you can just write a Python code, and whatever down there you want to run some like Linux stuff, you just put the command key, okay? It's like you are replacing this batch with just Python. So Python is kind of replace everything. So in Python, you can save a lot of efforts than other things. Okay. And I think Linux is built with Python installed by default. Maybe just Python 2 though. Okay. And that's also the reason they want you to replace the .shell, .sh file just with Python. Okay. Yeah. And let me see. So yeah, so how to submit your assignment? Right? So we have a lot of assignments where we will give you a bunch of cells. So this is Markdown, by the way. Okay, this is not code. Right? We will give you instructions, and you will have code, and you complete some code, and you upload. Right? You answer some questions in Markdown. Okay, right. So then the TAs they can look at your Jupyter Notebook file, right? Those files, but they have to create a Jupyter Notebook server. Right, and then they put your code to that folder and to read. Right. So this is a lot more painful to the TA if they do this again and again. So you can actually click File and click Download As, and click HTML, and then it will translate into HTML file. So you don't need a server, and the browser will be able to show it. Right? So try to upload as HTML. You can also upload your Python file as a backup, but the TA will, if possible, they will try to mark from HTML. So this saves them a lot of efforts. Yeah, so that's pretty much it for for this, and I think we still have 10 minutes, right? So we will demo briefly the first assignment. So the first assignment on Python is not a, so we are not planning to mark it. Okay, so we plan to skip it because it's for yourself, right? So if you are not familiar with Python NumPy, especially NumPy, okay, you should go through them yourself. Okay, so we are not remarking it to force you to finish all of them, but that's an assignment that you need to look at. Okay, so another thing is that we do have a very detailed demonstration of those stuff. But I don't want to spend time here because we have a video. So if you go to my web page, so I gave a talk on how to use those libraries. What are those libraries here at Quant? Okay, so you can check this video. Show language. So basically it contains everything. Okay, it's a little bit long, but you can take it some time. Maybe this is less than 2 hours because you can watch it maybe over the week and then get an idea of what Python can do and where we are. I will go through this file, but there's a lot of demonstrations of how these libraries are used, right? So these things I will leave to relay you to watch the video. Okay, so we will share those files for you to try them out. So some could be very powerful actually. Let me see whether we can show something. For example, here's an example. Let me just. So if you want to pre-process some dirty data, right? So you can use pandas. So the pandas allows you to just do import the library, and you have a CSV file. Just read the CSV, and then pad is looking at the first maybe 5 lines. Okay, so then you will be able to immediately get it into a table, right? So and this thing is array-like, so you can and data frame. Okay. So this thing is array-like. What does that mean? This is ND array, right? So this is array-like, which means you can, once you read it, you can directly pull, it can directly be converted into a NumPy array. And then you can throw it to something else, right? So for example, we talk about descending tree, right? So the scalar descending tree. Right, so if you look at when we want to train the descending tree, right? This is a hyperparameter. Okay, so how you want the descending tree to be, there's a lot of machine learning model parameters. Right? So let me see. But you want to, there's some functions. Let's see. This is fit. Fit is a training function. Okay, so this fit function, for example, if we look at here, right? This fit function has array-like. What does that mean? So anything that can be converted into a NumPy array is array-like. Okay, so if you look at the Python. So anything that can be converted into NumPy array. And if you remember, NumPy is the base of every data science library, right? And pandas data frame is array-like. Okay, so it can be converted into this format, and then you can run all kinds of machine learning. So this is one example, and a lot of pre-processing are in. You need the pandas to do that. Right? So this is a particular library. For example, you can add another column whose value is 1/10 of this column, called age by 1/10. Okay, and you can also do. I believe there's some data cleansing. So, for example, if you want to, let me see. For example, if you want to convert some value, right? So you can say, hey, I want this column to be numeric, right? because when pandas loaded, maybe it finds this column is not numeric. Okay, some numeric columns already float, right? But some are always. You want to find the reason. Okay, so let me play it. And there's sometimes it's not pandas fault. Okay, it's maybe the data you obtained from someone else, and the data has some issues. Okay, so you can see the error, right? So it says, hey, this data has 2 dots, right? It should be 28.3, right? But maybe your collaborator send you some noisy data, and you can see it at position 55. Okay, and then you can say, hey, I want to see these lines from 58 to 60. Okay, and if you look at here, you can see, hey, there's a bug here, right? So this guy is not careful when inputting this data. Okay, and then what you can do is you can say, hey, this is .3, not .3. Okay, and after that you convert to numeric again. You try again, right? So this should function. Okay, yeah. So if there's error, it will raise it. Okay, so yeah, let's see. I think. Yeah, so there may be some other errors. It will tell you which lines are. So some people make it like a timeline. Okay, once you fix that and you convert, they will convert to numeric values. So basically, there's a lot of like data pre-processing in pandas. Okay, so data cleansing and normalization, etc. Okay, some are in scikit-learn also. So like filling the missing values. Right? So by default, pandas have the missing values as a not a number. Okay, so we will not cover so much about pandas, but get a big picture, you will be able to explore this in yourself. Okay, you have a lot of stuff like how to classify image. Right? So you can get a random image from Google image and get a dog and say which kind of dog it is. So I will leave you guys to watch it. Okay, so just to go to my webpage, and here you will have the video on Python. Okay, and so this is one assignment that we will not be able to check your whether you finish or not, but we highly recommend to check it out. Okay, because we will save some time by just going through the slides and let you watch this video. Let me. Okay, we will kickstart a little bit and then we will take a break. So, yeah, so data science with Python, right? So why we will be programming with Python? Okay, so before I use Python, I use C++ and Java. Okay, so because they are really fast, a lot of people say, hey, Python is really slow, right? So a lot of people are actually not using Python because Python is slow. But these days, you cannot do that, right? So because all the libraries are in Python. Okay, if you do that, you lose a lot of stuff. Okay, so on your side, especially if you are pursuing data science, Python really is a language. So yeah, this is something you can skip. Okay, so what is Python? Python is really a programming language, but it has a lot of desirable features. And one is interpreted. Okay, it's not a compiler language. So this is the virtual and also the evil. The evil is really because it's interpreting line by line. It's really slow. It can be maybe 30 times slower than your C code, or even more, maybe 100 times. Okay, right. So for the same for loop, maybe you spend 30 times more just to run a for loop. Right? So, but the nice thing is that it's interpreted, right? It will look at your code and then run it accordingly. Okay, so that's why it can run with Jupyter Notebook. Okay? All interpreted language can run with Jupyter Notebook. Okay, and you cannot do that for C or Java. You need to compile it and make any change you need to compile. Right? That's really painful. Okay? It's object oriented. Okay, so they do have class. Okay, and so it's quite similar to C++ actually. Okay? Better than Java actually in terms of OOP support. Okay, it's a very high level. Okay, so you don't get to pointers, reference, etc. By default, it's everything may be reference. Okay, if you want a deep copy, you need the copy function. Okay, if you know what I'm talking about. If you don't, it's fine. Okay, so and there's a lot of building structures. Okay, so this is very important because these data structures are used quite often in your projects. Right, so in the old days when people learn C and Java, right, so they have to have a package to do these things. They are not building. You need to import like STL libraries for vector and the map, right? So for Java, you have the Java UTIL, those kind of packages, right? So, but in Python, it's really, you don't need to import any packages. It's just there for you, okay? Like a dictionary, it's like a map, hash map, okay? So because they are so common, they just make the language constants directly. So this interpretation is making it interactive, right? So this may lose some efficiency, but that's probably actually addressed, okay, by calling libraries. We will explain about shortly. And that actually make it even faster than your, for example, your Java code. Okay? Maybe comparable to C, because Python, if you look at Python, it's more like a shell. So it's not a it's more like you are writing a bash code. So each library you call are actually in C languages sometimes, in C++. I see some questions. Does array-like include the audio and image types? No, but there are libraries to handle those. Okay, array-like is really just an array. Array is a high-dimensional matrix, right? So if you have a matrix, let me see. But we will go through that shortly. Okay, so after the break. For projects, we will provide basically. Okay, we will provide instructions. We will complete part of the cells while we have some missing code for you to complete. All right, so yeah, I will stop here. So why we want to use Python, right? So life is short, you need Python, right? So if you write in C++, a lot of tension, right? So you avoid whether you miss a reference leading to a deep copy, and whether you have memory leak because you forget to delete something, right? In Python, you skip all those things. Okay? Maybe this is the same in Java, but then you also get interpretation, interpreted language. You have interact. Okay, so that's a lot easier to code. Okay, so let's take maybe what's the time now? Maybe 10-minute break or a little bit longer. Let's come back in 6:15. Okay, so we will start at 6:15 sharp. Okay, so don't come late. And thank you. Yeah, any questions? Please feel free to ask now.
All right, see you soon.
Okay, see you. Yes. Yeah, I'm still here. Okay, so I'm just yeah, stopping my video and have some dinner, and I'm just around. Okay, if you have a question, just let me know. Right, so I will answer a question. Oh, the teaming up will only be the final project, by the way. I see a question. Okay, so for the regular projects will be individual projects, mini projects, on the written side. Only the final project you can team up to 4 people. Okay, let's begin. Right, so yeah, so there's the things that life is short, you need to Python, right? So even if you previously using like other languages, I think Python is a good choice, okay? One student asked me Swift. I think Swift is really for iOS app development. I'm not sure. So, but I'm not sure any student who has an idea, you can just answer Chun Yao Chen. Okay, so, but I think mainly for numerical computing, right? So for the machine learning and deep learning, Python is right now like the center of all these libraries. So yeah, so I think Python is a good choice to start data science. So there are a lot of other choices, right? So, you know, I think maybe Oracle even has some machine learning libraries they want to promote Java libraries, etc. Right? So, but you need to look at maybe 99% or 90% of people, what are they using? Right? So this is a community, and then a lot of people are contributing things, and the latest algorithm are, you know, is implemented in those libraries. Right? So if you use not just Python, okay. So if you look at deep learning, you know, there are different packages like PyTorch and TensorFlow, right? So if you are using something like, I think there's other libraries like I don't remember some name, maybe MNACT or something, right? So other libraries, and then maybe the latest models are not there. Okay, you have to implement yourself. Okay. So yeah, let's begin. Okay. So what is Python, right? So Python has several features, right? One is interactive. Interactive makes it easy to use, right? Just like why you write the bash code, right? So, but the unfortunate part is that it's super slow. Okay, so yeah, it's very slow to run directly if you want to do some workhorse task, right? So usually you call libraries because the library is actually written in C. It's fast. Okay, C++. Okay. So C++ is a native language, right? So it runs super fast. But when you write the code, you kind of have a lot of tension and mistakes and debug. It's a lot slower. Okay. Java removes a lot of the concepts, right? So basically, it starts as a reference, right? Everything is pointer now. Okay. So you don't do deep copy. Okay. So you don't need to delete things. It has a garbage collector, right? So it's a lot easier to code, and it's still compile language, so medium speed. But I think you know you want to both end, right? You want to fast and fast here, okay? Right? So Java kind of slowly, you know, not taking the trend because most people now no longer use it. Okay, so for new projects, maybe old projects, Apache projects, a lot of us doing Java. Okay. But if there's not much new stuff there, right, over the time it will fade out. Python is really getting a lot of momentum. Okay, so it's very fast to code your program in Python, right? Maybe 10 times faster than C++, right? So it's human productivity. This is the execution speed. But when you run, maybe it's 30 times slower than if you write in C, right? So that's maybe undesirable for you. Okay, so here we want to achieve both fast, right? The speed should be as fast as C++ speed when executing, right? But when you write code, you want to write in a relaxed mood, right? So you want to have a lot of libraries, right? Like in the Python. Okay. So does the slow speed of Python matters? It depends, right? So a lot of tricks are used to speed up, right? So for example, you can use Python. It's a compiler language, it's non-interpreter, right? It's actually compiled to C or C++, but it gives you the Python interface. Actually, most of the libraries, I think, are open, written in C and then open to Python using Python. A lot of them, at least, if not most. Okay, you can look at the explanation here. Okay. So, like we just discussed, right? So in scikit-learn, right? So we have the decision tree libraries. Okay, so if you look at it, it's actually down there. It's in Python. Okay, so it's much faster because it's actually running in C. Okay, and for you, it's 3 lines of code. Right? So import the model and fit. Right, and once it's fit, it's predict. But maybe you need to load the data using pandas also. Okay, but maybe even if you write in C, decision tree, it's not faster than this because it's already coded in Python and it's really fast. Right? And you can view Python as advanced shell. Right? So you have a lot of programs that you write and compile, and then you use your Linux shell or Bash in Windows to connect them. Right? And you never complain about this shell is slow because the workhorse is done by your program that you are calling in shell. Okay, it's the same thing in Python, but Python is a lot more powerful. Right? So the language is way more powerful. Okay? But when you call libraries, it's kind of like calling the shells, those C programs in the shell. Okay, so here's a explanation that's from this link. Stack Overflow saying that NumPy arrays are densely packed arrays. Right? So and NumPy is implementing C. Okay, so you can see that. So this is quite a phenomenon, right? So because we told you that when you do Python, right, and then you use NumPy, and then all are on top of NumPy. Okay, so basically everything is benefit from this C part. Okay, if you do numeric computing using NumPy, maybe way faster than write your own Python code directly. Yeah, so try even to avoid writing your own for loop if the library does that for you. Okay, let me see whether. Yeah, let me give an example how a particular library avoids you to write for loop yourself. Okay. I think I need to have a browser there. So let's go back to the scikit-learn library. Okay, scikit-learn. So, in this kind of machine learning models, you first need to train your model. You build a classifier, okay, giving the data set. Okay, so this function is called fit. Okay, usually this X is something like let me give it the image. Let's go to Google Image. I believe there's a table that you can. I do need a table also to show the length. Yeah, that's good. Let's look at this particular example. Okay. Right. So in this machine learning model, you have a bunch of attributes, right? So like humidity and the temperature, and then you want to predict whether in this weather, for example, whether this person will play golf or not, right? So you can build a decision tree, right? So for example, if it's sunny and maybe so yes, this may be some random decision tree. Right? So I don't know what it means. So but maybe according to the data, you will find this row that we targeted looking like this. Okay. Right. So this X is what you can load CSV from here. Right? So you load this X, you can load this Y. Okay. You can even load CSV together and then split into the X on the left hand side of the 4 columns, Y. Okay. And then you will put this XY into fit. Right. It will train this tree for you. Okay. Try the tree on the right hand side. After that, the purpose is really not using this table. Right. This table is already here. Right. What you want to really give a new person, right, with this kind of conditions, or give a new day with these conditions. You want to predict whether this guy will play golf or not, right? So this is one row, okay? So ideally, you can just give a row, right? And just let it predict the label, okay? Right, so this is like this function. But in reality, scikit-learn libraries are all something like this, right? In predict, you give the whole X, right? So let's say these are the test data, okay? These are test data you have. And you don't really already know the labels here. Okay? You don't already know these labels. These are what you want to predict, okay? Right? And you don't know them yet. Right? So what you will do is, one way is you can give this row, and that tells you yes, right? Another give this row and tell you why. No, right? Because you have the tree, you can go to the attributes and go to yes and no, okay? But that means you need to write a for loop over these rows and get those labels, right? So even this is too slow, okay? Because you need to write a for loop in your Python code, right? So this is avoided here. Right? So you can see this X is directly how many samples and how many features, right? So here samples are the number of rows, features 4. Okay? So directly give this to you. And it will return you the entire column Y. Okay? It's the entire column output. Okay, the entire column Y. Right. So this is, you can see that even like this second library, because down there it's running NumPy and this for loop and even matrix operation. This is way faster than if you write your own for loop to do prediction. So just give all the test stat. Okay? It will give you a column Y. Don't write your for loop row by row. Okay? So this is a particular example of how the library is designed to avoid you to write direct Python code. Okay? So in that sense, actually, data science is really no more models and know how to call them, right? So it's a flat structure, right? So you don't need to code too much things down there, right? So if you want to devise a new machine learning model, right? So and run really efficiently, right? So like kind of like a new decision tree kind of model, maybe you should write in C, okay? And then using Python to open Python API. But usually, these common models are all in those libraries, so they should be sufficient. Just combine and use them. So yeah, so this is the view. You view Python as a raster shell. Okay, don't write everything yourself. If the library handles this, that the library will be way better, much faster. Okay? Another example is TensorFlow. So I think PyTorch may be in Python, I'm not sure, but TensorFlow is written in C++ and CUDA, right? So because we want to work with NVIDIA's GPUs, right? So CUDA is a C API for GPU, right? So down there, TensorFlow is a highly optimized C++ and CUDA. But up there, you are writing this kind of code. Right? These are all Python code, okay? Right? Actually, down there, the last layer is all those kind of numerical operations that are happening in GPUs. Okay, these are happening in GPUs. So actually down there is highly optimized C code there. And when you call TensorFlow, you're actually running C. But high level, when you design model, you definitely want to Python, right? Because C a lot more difficult and not necessary. Any questions so far? If not, we will begin. Okay, so what Python wins, right? So an important thing you need to now notice is this. So Python, when you write Python, you are fast, right? So because maybe the other guy only knows C or Java, so coding maybe 200 times slower than you because they are writing that decision tree. Okay, right? Okay. But you are getting the same speed, even faster speed, right? So because this guy may not implement as good as the library in second. Okay, so really we are having the speed on both parts. Condition on that, you learn a lot of libraries. Okay. All right. So another important reason is that Python is interactive, right? So of course you cannot not go down and tweak things inside each function in Python because maybe down there is, but in between the interface, right? Each Python code you can try an error, you can you can rerun and you can change the code and fix some bug and run again. So okay, so that's pretty nice. So and so you can write, you can just open the browser, right? So you can even use the Collab, okay? and then you can run and find some bugs, and then you can rerun it after changing the cell. Right? So that's very user friendly, and it's really interactive. Right? You don't compile. Okay? So that's a big win. Okay, so let me see. Any questions? If not, let's continue. Okay. Yeah, so these are the repeating of the step. Right? So you can also follow our slides. So I will quickly pass it. Okay. And see that some of the points. There's a lot of other things you need to study over the when you are using this stuff. Right? So, but I think these things are enough to kick you start. Right? So then you can Google and etc. Okay. Right, so so these are the Encoding. Okay, so we will have a demo of how to use Jupyter Notebook and the Python language. So let me stop sharing and do some quick demo. So have a next step here. Just show you that. Okay, so right, so I've already sent a 3 announcement. Okay, so let me look it. So there's a video for Python I just shared here. Okay, if you click there, this you can watch it directly if you want. So it's on YouTube actually. You can click YouTube. You can go to YouTube. Yeah, be sure to watch and get a better idea if you're not familiar with those Python libraries and what Python can do. Okay, and another is we have a warm-up assignment. This is what we will be done. Okay, so basically this assignment one package you will try to go through it. Right, so it's too much for me to go through it here. Right, so I will briefly tell you what it is. Okay, so and then you will spend most of the time to go through yourself, right? So because it's an assignment, but we will not mark it. Okay, but be sure you go through it so that you have the background to proceed with later assignment. Okay, so here what you will do is you type a Jupyter notebook, right? So you will create a Jupyter notebook and this folder. Okay, and you have 2 files. You will not see anything elsewhere. Okay, just end this folder. So it will create a you can see everything under this folder. Okay, so you can create new folders. For example, if these are totally totally synchronized. Okay, if you create a new folder, it's here. Okay, then you can. So wherever you create the Jupyter notebook, you will have this folder. I installed Jupyter notebook without an Encoding, so I just directly type it. Okay, one in this folder. And yeah, so this is basically a Python tutorial that we will give to you to do some practice. Okay, so let me quickly go through something. Right, so firstly, for example, if you can run something, right, run something, and there's a JavaScript magic command. Okay, so this is like a manipulating the constructs here, right, on the web page. JavaScript is just deleting some cells, etc. Okay, here clear all output, like these outputs we currently have. We can clear them. Okay, right, it's gone. Right. So this is very simple. So you can use a type command, say, hey, what's the type of this data? Okay, and you can change this to later to, let's say, this 3, right? So you can change it later to a string. Okay, so you can change it to AGC, right? So it becomes string. So this type can change. Okay, and if you look at the, these are the operators. But I think maybe, let me see. Oh yeah, I just changed it to string. You can rerun this, right? Change it back to integer. Okay, and then you can run these and okay. And you can even, let's say here, let's add a for loop. Python using the tab to decide. So for I in range range maybe 1,000 means, you know. But this will explode. Right? So let's try to let's okay. And you know, so this basically is saying that I will loop this maybe without this, okay, for 1,000 times, and each time we'll print this, okay. So something like this. Okay, you see that the output is 1,000 lines. It's too long. Okay. Range means 0 to n-1. And you can do this, and then it will be shown to the bottom. But sometimes you don't want, right? So this is the button. If you click again, yeah, you can scroll the bar. Okay, so these are the constructs, and then you may find something wrong. Right? So like what I just did, change the string, and then you can come back and change. And in Python, we do use uppercase transfers, right? So and we use these keywords. Okay, and this is to the power. This is the star. This is to the power exponential. And I think these things I will leave to you guys, but I want to particularly emphasize some data structures here. Right? So the first is list. Right? So list is something, I think there's a chat. So there's a student asking, how does an Encoding track with Jupyter Notebook, if at all? So Encoding environment, if you enter Anaconda and the Jupyter Notebook installed down there, then you can just, you know, it's like a console. Okay, so if in the console you say, hi, I want to enter this environment. These packages will be loaded. Basically, you can use it as if you are having these packages installed. Okay? And if you exit, they are unloaded. You go back to the operating system libraries. Okay. So it's like an environment. Okay. Right. So here are the lists. So firstly, what is list? Right. So I see another chat. Yeah. So how come this is? So a list is usually an array. Okay. So this array, when you you know, down there array in computer always have fixed size. Okay. So there are usually two concepts. One is one is the list, right? One is size. For example, now you have 1, 2, 3, 4, 5. Okay, 3, 4, 5. One is the size. Size is 5. Okay. Another is called a capacity. Maybe a capacity tank. Right. So what will happen is if you write to the last element and you want to write a new one more, right? There's no capacity anymore. Right. What it will do, it will release all the space and create a new space. Right. And copy these items here, and the new item will be inserted here. And you can show that the amortized cost of this solution is still constant. Okay, the reason very simple. Let's say you have n items, and you find your space is full. You want to use two n items, right? But after you this cost, maybe you create a 2 n items cost. But then you can have n items appended, continue to append them, right, with all n costs. So that's pretty easy. That's it. So here, so one important, I think one. Here are showing like this is list 3, 1, 2, right? And this is 0 item, okay? This is 1, this is 2. So let's see what it is. Okay, so this is the whole list that we printed, and this is 2, which is the third item, because it's 0, 1, 2. Okay, -1 comes from the last, right? So this is -1, -2 will be 1. Okay, but list is actually used most often using append. For example, if you have access right now, right, so like this, if you can append another item, okay? Okay. Then if you show access again, it's full. But append and pop, I don't remember whether it's pop, but let's try. So you can look at the API. Okay, it pop out 4, and then you only have. It's like a step, right? So because you can shrink and double the space, right? Down there, all of them are like C, you know, using Java or C new. Okay, so yeah, I see another question. So maybe we can. Yeah, so here's what you do, right? So if you use so in the console, let's say I think as a student, let's ask this question. Okay, let's say you install Python, okay, but you don't install Jupyter Notebook, right? And if you are doing anything like Jupyter Notebook here, your operating system will not recognize. Say, hey, I cannot find the Jupyter Notebook command. Okay, but then you say, hey, source activate your environment, because the environment installed Jupyter Notebook. It will load Jupyter Notebook into your background command. Okay, and then you type it, it will find it. But if you exit this virtual environment, this Jupyter Notebook will no longer be found because it's unloaded again. Is this clear, John? Yeah, you can unmute yourself and ask. Okay.
Sorry,
Yeah.
a little bit.
Yeah, yeah, it's fine. So let me tell you, right? So for example, if you look at those commands like ls, right, list, right? So it's actually there because it's loaded. If you have ls, it doesn't understand, right? But if you enter environment that ls is installed for you, you will be able to recognize it. Okay.
I guess my question is, say you have 5 different Anaconda environments. Does the Jupyter Notebook attach to each one of those separately, or can you have the same Jupyter Notebook with different different environments?
You usually do this, right? So you are in your operating system, right? You enter this environment, and after you exit, and then enter the other environment, exit the other. I don't know what will happen if you enter this and then enter that. Maybe it will give you an error, right? So, or you may load both of them, but if you have conflict, you have to handle that yourself. Usually you don't do that. Usually enter one and exit one and exit two and exit two. Something like that.
Okay, the reason I'm asking is I had a different environment from another class or something. So if I'm in a Jupyter Notebook and I deactivate one and I activate the other environment, I'm now using those packages?
Yeah, so depending on each environment, you can install your software. Maybe they have conflict, right? So you may want to just use one environment, okay?
Okay.
Yeah.
Thanks.
You're welcome. All right, so let's see. Oh, what happened? I think that window has another window here. So I think we are disconnected. Let me start. Yeah, because we open a tab, which means it's just near the previous one. Okay? So you can see that it's auto-saved, but if you want to save everything, you need to click the button save. Okay? Otherwise, we will probably be losing some of the content. Yeah, we still have something there, but we lose something. Okay, yeah, so we still have them. It's auto-save. And this thing you can change it to, you can change it to something like, it says not defined. Oh, because we have a new environment, we need to rerun this, okay? And then access load. And then you can change the item of, the last item to full, right? So it can be, it doesn't have to be the same type, like in C++, right? So even in vector, you need to have the same type. So this is a data structure. Okay, so if you are interested, you can also go to, yeah, I think I can send it one. We will also use YouTube to release our course videos. Okay, so that you can rewatch yourself as much as you want. So if you look at the videos, right? So we have playlist. We have the training. If you're interested, you are welcome to look at this video. Okay, so we have all kind of data structures. So these containers, like set, list, etc., are all like data structures. Okay, so yeah, you are also welcome to subscribe to the channel so that you can get notified if you have new video shared. Okay, so let me send an announcement. Yeah, you can watch this video, and it tells you, see things in all kind of languages. Okay, C++, Java, Python. Okay, for example, if you look at the this thing here, in C++ we call it vector. In Java we call it array list. So they have different names, but it's basically the same thing. Okay, and you can append, you can pop. Okay, and slicing is like you can get a sub element of it. Okay, so for example, if you look at range, right now range is an iterator. Okay, iterator means you have to get a list so that it will show the. Okay, and you can also get, let's say, 2 to 4. Right, the key thing you pay attention. This is inclusive. This is exclusive, which means you look at these things. Right, this is location 0, 1, 2. 2 is inclusive. Okay, this 2 is inclusive. And 4 is exclusive, which is 3, 4 is exclusive. Okay, so what does that mean? That only includes 2 and 3. So if you do this here, it's just 2 and 3. Okay, so it's always left is inclusive, right is exclusive. Okay, in all programming languages almost. And there's also loop list compression. Right, so list compression maybe we can describe a little bit. Okay. So this is saying, hey, for each item in nums, 0, 1, 2, 3, 4, right, we want to take square, and we get this. Okay, so there you can also not consider 1 and 3 if you wanted them to module to 0. Okay. Then you will get 0 for 16. Let me see the time. Maybe we should really get quicker. Okay, so dictionaries. Dictionaries are kind of special. It's like hash maps, right? So you can watch that video, you can understand more. Basically, we want to, in array, right? So we have the index, right? So let's say this is 0, this is 1, this is 10, and we can quickly get this item, right? Using, let's say, list A10, okay? This is, of course, fast because our memory is a random access memory, right? But what if these keys here are other things, right? So like strings, or, it can be maybe not dense, right? Sometimes you have 1, sometimes you have 10, then 11, then 100, right? They are not dense. How can you still keep all one-time access time? Right? So there are data structures like hash map, hash table, right? So this thing is actually a hash table. This tells you that this is the key, this is value. Okay, so pay attention that in Python, array, or you say list is these brackets. Okay, so in dictionary, it's more like a set. Right? Those brackets are right into set. Okay, right. And if you have key value, you are separate by column. So this cat, cube, dog, furry. I think there's a chat. Yeah. Okay. So if we run this, okay, so you can see that the cat in. So one thing you pay attention to, this in. Right, so it's that whether it's in this dictionary, it's only look as keys. Okay, so for example, if you do something like print dog indeed, it's actually true, right? But you say the value is indeed, it will not be true. Okay, it will be false. Right, so it's looking. So in operator only looks as key. Okay, and because it's a hash map, right? It's really a hash echoing key. Value you can give anything. Right, so. And you can also here, you can change, you can insert a value. Okay, so let's say we want a fish to be wet, then this will be inserted. Okay, right. And if you come back and print D, it will, I believe it will include fish. It now includes fish. So this is the insertion operation into the hash bucket. Okay. And you can also print a monkey, but this time you don't give the key, so it's like reading, it's not writing, right? So it will have no monkey. It's a key error. And you can say if you really don't want this kind of error, you can say, hey, if it's not monkey, you just print not available. Right? So then this will be able to. Okay, and you can also delete fish. Right? So previously we have an item fish here. You can do, but I think these are too detailed, so we'll go really fast. Okay, so let me see. The next is set. Set and the dictionary are basically the same, but you don't have values. Okay, you don't have values. So again, if you are really interested in how they are implemented down there, you can go through that video I shared. Otherwise, you can skip that. Okay, so for example, if you look at binary search tree, right, black tree. So these are really something that organizes against key value pairs. Right? So this is set. Right? So how to do login time, you can which things. Right? So this is like a set or dictionary, but So that is more like tree map, if you know what is in Java, or map in C++. But if you look at Python, it's actually hash structures, okay, hash tables. So this is more like you know, more space but less, you know, searching time. Since in Python, it's using this kind of data structures, okay, to achieve something similar to a vector, similar to a list. Okay, so you can give the key and see whether it's there or what's the value associated with it. Right? And there's a way to write loop, right? You can give an enumerate, then you can associate the ID. Right? So this is the first item, second item, third item. Okay, so but the set is, the order is not determined. Okay, so maybe dog goes with this. If you use something like a list, then you know, the order will be clear. That's so because, you know, it's like pushback. That's the first way. The set, it can be any order. So determine it internally by hashing. Okay. So yeah, so these are pretty much these contents, right? Tuple is something special. Okay, tuple is a tuple, right? So tuple is something special. Right? So one particular thing, tuple is like a list. Okay, like a list. Okay, but it's a fixed size list, right? So list we can append, tuple we cannot append. Okay, so for example, if we look at D here, which we just have it, right? So the key can be a tuple, right? So and let me create a tuple. 0, 1, that will print 0, 1. Okay. This is quite similar to MATLAB. If you have a semicolon, I think it will not print. If you don't have semicolon, the last line will be. Okay. And similarly, if you return something, right? So define get ABC. Okay. ABC. You return something. Okay. Return it. Okay. Right. Then if you it's a function, so you should have some input. If you have returned something, then you call ABC, it will come. A equals to ABC, then that's in A. Oh yeah, so we should have the we should have the meaning that we are calling. Okay, so if you have something returned, if you call this, right, but you don't have something to collect it, it will just collect to the here. Okay, but if you don't have anything returned, right, so it's an empty, maybe pass. Okay, then it will have nothing. So if you return something but you don't collect it somewhere, it will be collected. But it only collects the last line. Okay, it only collects. We need to run this again. It can only collect last line. Okay, so if you want all of them, you need to print. So the first can use print. The last one can be saved. Okay, something like this. Okay, so and if you put in the same line, it will print with the space in between. This is like inherent, right? So. And so one thing you need to pay attention is the single item. Okay, so single item. So for example, you want to have a tuple which is 0, right? So it will be just 0. Okay, you want to have a singleton, you have to have a comma. Okay, in this way to understand. But for more than one, then you don't, because there's ambiguity if you just have this. Right? It can be just 0 item without container. Okay, so that's something that you need to pay attention. Let me see. Yeah, this is API that you can. And you can even define functions, and the function can return different values. Okay, for example, you can do this, sign negative, but negative, maybe you want to return -1, that's also fine. Okay, it will return something. Okay, and so yeah, so these are basically containers. There are a lot of things like OOP programming. We will not have time to go through all of them. Okay, we'll leave to you to get familiarized. One thing you need to pay attention is this. So for example, this self means the current object, right? In C++ or in Java, this is this, or this pointer or this object. Okay, in Java, C++ it's this pointer. But here, we by default, you need to have self in the first argument. Even though when you call it, you are just getting value. Okay, if you don't have self, it may refer to some global variable. Then think the money is this worker. Okay? So that's something a little bit different, and also. In Java or in C, you have new object, right? So here you don't have it. Okay, so you just create an object by default. It's like in Java, you have a new. Okay, so just create an object of this type, and then you get it. Right. I think, yeah, so now let me see the time. We'll go quickly through some NumPy things, right? So if you have a list, right? So the list is still a data structure, right? So you can append, right? If you really want to wrap it into a NumPy array, once it's in NumPy array, it's you know, you are using some like a block matrix computations. Okay, so let me show. Right, so you are using cache efficient implementation. Okay, so there's a lot of operations down there. Maybe if you use different orders, there will be different execution speed. So there's a whole branch like matrix computations work. Right, so talking about this, right, and see whether you really want to touch those things. If you don't want, just do the NumPy level. It's a lump. Okay, so basically what it means is that maybe doing matrix multiplication, if you are doing that, right? So what you do is you do the first row times the first column equal to this value, the second row, second column. This is going to be super slow because down there, the computer using cache, right? So you want to make some blocks, okay? And then you can reuse some of those things before they get out of the cache, okay? So there are some cache efficient parallel programs that are supported by NumPy, but if you just write those things yourself, it will be slow. Okay, so this is again a data structure, right? So you make it into a NumPy array, and then it will become NumPy. Okay, and then you have support all kinds of matrix operations or tensor operations. Okay? Before that, you need to import this library. Okay, and then you can have A into this A, and you can say now this is a NumPy array type. Okay, and the shape right now is one dimension. Right? This dimension has 3 items. Okay, so this is the tuple. So we have the comma here to show that it's not just 3. Okay, and you have the the first element, second element, third element. Right? So you can change the first element to 5. And right? So let me see. So this is 2-dimensional. The first row, the second row, you write the array list. Right? So then you get 2-dimensional. Okay, and then you can use index together. This is the 0th row, there's column 1. Okay, this is maybe the first row, which means this is the first row, right? The 0th column, which is 3. Okay, so the shape is 2, 3, right? Because you have 2 rows and 3 columns. Okay, and let me see anything important. You can create an initial values. Okay. This is quite similar to others. Again, this file is given to you, so be sure you go through all these things, right? So NumPy has a some. Let me give you some examples of what you can do here quickly. Maybe you don't have to go through all of them. For example, if you have this array already, right? So let me see, this array already B. Let's make it the simplest example. Let's consider if we want to sum all their elements, right? So you can use b.sum or numpy, right? This is 21. Right? And what if you want to get the sum of each row? Right? So if you want to get the sum of each rows, what you will do is axis equal to 1. Okay, then you get this sum of each row. This is 6. Right? This is 15. Okay, and if you want to get the columns, it's 0. Right? So we may confuse, right? Sometimes people will confuse 0 and 1. The reason, for example, why we give 0 is because this actually you are marginalized out, summing out the rows, right? And what you get is column. Okay, right? So you are marginalized on rows. Okay, so rows are 0. Okay, so you are getting a column vector, right? So 6 and 15. Okay, but the reason it's like a one-dimensional is because you don't keep the dimension here. If you keep the dimension, let's say there's some other options that you can study. Key is equal to true, maybe this. Okay, then you will get a column array. Okay, column array is 2-dimensional. Okay, so you can I think transpose it. You can transpose to 1-dimensional. But this is still a matrix, as you can see. And there's actually the nice thing about NumPy is it's an array. It's a high-dimensional tensor. It's not just a matrix like in MATLAB. Okay, and there's a lot of things that we will potentially leave it to you to study. Okay, and be sure to go through these things, including how to plot stuff. Okay, these are very important, and be sure to go through this file so that you get an understanding of all those concepts. Right. So I will not go through all of them. Otherwise, this will be the end of this course. As we spend the next half an hour. Okay. Any questions so far? Okay, so let's continue. Yes, this is a demonstration of NumPy. Okay, so Python and NumPy. Okay, Python has a list, etc. And so why Python wins? Right, so one reason is because of speed. Right? So they are calling C libraries, and the C bars are complete, right? And it's when you call these libraries, this code is in Python, which is very efficient to write. Okay. The second reason why Python wins is because so many libraries. Right? We have seen this some of the libraries. Okay, so like you want to load some table or some time series and do some processing, you can use pandas. Okay, and after that you can throw to some machine learning model in NumPy, right? Okay, and then NumPy is the base of everything. You can throw to scikit-learn. Okay, there's a scikit image or something. Right? So scikit means scientific computing. That's a scientific kit. That's a lot of libraries. Okay. And then you can, if you want to plot things, you will use a matplotlib. Matplotlib, because there's a pyplot library under it, which is used a lot. Okay, you can plot anything. It's almost the same as ggplot, but it's much easier to use, and you can write in Jupyter Notebook. Okay, and so these are pretty much three libraries, right? So down there is NumPy. Up there you have pandas to load data and pre-processed data, right? And then you use scikit-learn to do machine learning, and using matplotlib to plot in. Okay, and you also then, if you want to go to deep learning, right? So if you go to deep learning, you might want to watch some, let me sample. You might want to go to some videos teaching you how to do that. Right? So let me stop share. Share my brother here. I think this particular video is very good in terms of TensorFlow. I think this guy actually rooted in PyTorch. Right? So, but TensorFlow tutorial also very good. So, but you do need some background. Okay, so he assumes that you already know deep learning. Okay, so and if you go to the channel, and you can go to TensorFlow tutorial, or you can go to the PyTorch tutorial. Okay, so these are very good deep learning tutorials. Yeah. So if you need a link, just send an email to me. I will share this channel with you. I think this is probably one of the best tutorial here. So this is if you want to do deep learning, but you first need to know the deep learning concepts. So what is convolution net, what's a recurrent net, what is a transformer, etc. What is a adversarial neural network, adversarial again, right? So generative adversarial network. Okay. And you can also do natural language processing. For example, if you want to do some parsing some words, right? Get rid of some stopping words, etc. Right? So we'll use a library called NLTK. Right, and if you want to do some topic modeling, like latent altitude, LDA, right? So you will use Jensen. Okay. So why everyone is doing using Python? Right? Because even though Python is so slow, but everyone is opening their backend, maybe in C, maybe in other language which is much faster than Python, into API that's in Python, and you are just encoding these API. Okay. So if you don't learn libraries, Python is useless, right? So, okay. And so, yeah, this is the data cleansing, data processing, pre-processing. I showed you by the YouTube video that I recommend you guys to watch. So I will skip this. Okay. There's a demo on machine learning that I will do right now because we probably still have some time. So are you seeing my slides? Just want to make sure.
Yes.
Okay, that's good. And yeah, so we will go through this, and we also have something shared. You can look at my announcement there's a like word2vec, which is topic modeling, right? So you let the model read a lot of text, and then each word will be embedded into a vector space where you can compute like the distance between two words. Right? So it's like like the DC towards US is very similar to like London towards UK. Right? So you can have a so the vector from country to the capital. Okay. And let me see. Yeah, so this is how it works, but I probably will leave this to you to study. Okay, so, and there's also like transfer learning TensorFlow, which means Google maybe spend millions of dollars train the model already, and you need to you can reuse some of the training, but you need to change the last layer to your problem, right? And then fine tune a little bit. Okay, so I will leave these things to you guys to read. Let me go back to the machine learning part. Okay, so how to use machine learning. Let me stop sharing. Okay, so we are back here, and if you look at the announcement. Yeah, again, we have a lot of things here, right? So if you have time, try to go through them, but that's not, you don't have to understand everything, okay? This is just to give you a good mindset of how to move ahead in data science. Okay, so we have a warm-up assignment. So we have this assignment, which is Python thing, okay? We also share the code related to demos. So the demo, you will watch the video, and then you can download this to play with it. Okay, we share some pre-trained topic models for you. And this archive.zip is actually some machine learning. Okay, so you can open it. And here. And if by doing this, we should be able to see it's done here. So let me see. Yeah, it's here. Okay, so now you can try to see what's happening here. Right? So I think this is the data cleaning demo. Okay, so we can see whether we have the data here. No, we don't have the data. The reason is because this data is shared by some collaborator. We cannot directly give you the code, but you can see what's happening there. Right? So for example, we load a particular data table here. So and we want to really change a particular column. Let's say this column. Okay. This column, right? So this column is really strange because maybe this is missing value, but so you can use count of the data frame. So firstly, what you can do is you can import pandas and read this CSV file, and you will get those columns. Okay, and then we are interested maybe in all these 5 columns. Then we can use a column index to get only these 5 columns. But then if we look at the, we can add another column. Let's say this is the age, okay, and we can use divide by 10 to get another column, okay, which is 1/10 of this age, right? So just think about how much effort you need to do in Excel to do this, right? So you can see that pandas are really winning in a lot of aspects, okay? And there's also in-place drop, right? So by default, it will return a new table if you just drop. In-place drop means I just work on this table. I will drop a particular column, which is maybe this age. So this age is dropped, okay? You cannot see it here. You see rest column. Then we can count, right? So the count is saying, hey, I want to see, how many missing data so are there. So you can see this not number are considered missing. I think it's a not missing data. Right? So and then these are missing data. Right? So you can have the length is basically how many rows you have minus those count, which means those are not a number, are not counted. Okay, and then you get these are the number of missing data. And then you can do some data cleaning. So you can see, hey, what's the types of each row, each column. You see object flow, right? So object is like the it's not a number, right? It's a class of any object, right? Just like in Java, right? But this doesn't make sense to you if you think about this column. It's just numbers, right? So then we need to figure out why this is happening, right? Then we will convert this to numeric, also in pandas, right? Okay. and raise the error if you see so. And here we will raise this error. It's in the 55 position, we have this. And then we go from 50 to 60, we find, hey, this 55 really has a problem, okay? And then we just fix it, right? This is data cleaning. Again, we don't have the data, but you can see what we run here, and you can figure out what's happening. But after fixing this, then you say, I want to change it. You can see that it's successful change. Right? So this whole column only have one mistake by a human, just 2 dots. Okay, we can continue to check another column. Right? So this column has this error, and you can fix it. Okay, so you can see this thing is pretty. If you know some of the libraries in pandas, you can do these things pretty quickly. For example, here you can see this. There are 2 categories with drugs, right, in that column, but it's written by human, right? So sometimes you have typos even. Right? So this is and this are the same. Okay, so altogether, actually, you only have 2 types. Right? One is this, one is this. Okay? So what you can do is, hey, I want to replace all these names, one with 1, another with 2, right? And become numbers. Right? So here's what we can do. After replacing, we can get so many 1, drop 1, this is drop 2, right? And after pre-processing, we can. And this thing now can go to a machine learning model. So claim the data and save it to disk. Right? So here index, if you don't say index equal to false, what will happen is that you will also save this row index. Okay, so usually when we say we don't want this first row index, we will display equal to false. Okay, but I think we cannot share that data, so you cannot play with it. You can try to go through it and try some other data sets. Okay? And regarding the other models, right? So let me go through the forest model. Oh yeah, so there's a student asking about the tenants. So for this class, we will skip the tenants because still during the add drop period. Okay, starting from next time, we will take attendance from tenants. Okay, but it's pretty important this class. Okay, to really go through all these things that are shared so that you get an impression of what are there in data science. A lot of things already. Okay, pretty packed. This thing we can try out because this data set is actually this data set is actually here. So it's this data set. This is CSV file. Okay, CSV means comma separated vector. So it's a vector with comma separation. Okay, and you don't have to just do read CSV. Okay, so if you have Excel, you can read Excel. Okay, in pandas. So they have all kinds of reading function. Okay, so right now we just save out CSV, then you can read. Let's clear all the output. Okay, and then we can see what's happening. So here we are doing this, right? So we want to read this data, but we don't want to get all the columns. Some column may be IDs or something we don't care, right? So and this, I think this table does not have the header, unlike the previous one. We have the header, right? So in that case, you can tell the pandas table. Okay, these headers are like this. So sex, the first column. Okay, right. The second column, this thing is, for example, the length of maybe a flower. The petal of the flower. I don't remember what this problem is. Right. So then you have this header there. Okay. The header now means the data does not have header. Otherwise, it will treat the first line as an attribute, which is undesirable. Okay. And you say header is none, but I will provide a header like this. Okay. And not available values by default is not a number. But actually, in our data table, it's question. But look at here, we have some. I think we have some question mark. Right now, I cannot find it, but sometimes missing values we use question mark. Then you need to tell pandas, hey, don't be confused when you see question mark. It's missing attribute. Okay? And then you can load and you show the first one. Okay. And so here you can see the order is. I see someone plotted. So let me. Okay. Yeah, let me clear order. So here you can see that So by default, head only shows 5. Okay, for example, if you just use head, it shows 5. You can say, hey, I want to show 10. This is like head in your command window, but command by default is 10. Here is 5. This fraction 1, it means it's the whole fraction you are doing running something. It's like a shuffle of the data. So you can see the IDs are different. Right? And each time it will be different. Okay, so the reason we want to shuffle the data is very simple, because you want to predict something. So here, for example, we want to predict in the rings, how many rings you have, maybe a tree or something. Okay, so maybe the data is sorted in a way that is undesirable. Right? So all the beginning are small rings, all the data rest are large rings. Okay, then if you use the training data, you only see the small rings and you want to predict the large rings. It's not possible. Right? So we'll shuffle it so that it's in random order. Okay, so then you can do something very interesting. For example, you want to see the sex column. The sex column has the male, female, and infant. Okay, infant is kind of like they treat it in the middle. Maybe this animal can develop to male or female. Okay, so you can see, hey, how many male, how many female, how many infant. Right? So you can use value counts for different columns. Okay? And then you can let me see this. I think this is removing this. Get dummy is this column is a string, but in pandas, in scikit-learn later we need a numbers. So this is called one-hot encoding. Okay, so if we do this and we tell the sex column should be one-hot encoded, so this column will go to 3 columns. Right? So this is quite making sense. Right? So this is like a particular attribute which is female. This is a particular attribute which is male. Right? So they are like independent numbers. This is better than you give a score. Right? Why you give, you can do something else. Right? You can say, hey, this is 1, this is 2, this is 3. Then it's like it's like a score. Right? They have the magnitude matters. That doesn't make much sense. Okay, so this is more making sense. This is like, hey, whether this female is activated or this male is activated. So this is one way to do one-hot encoding. Okay? Getting those dummy. So this is basically the main, and these are the different values that occurred here, which is here. So this is so pandas have a lot of this kind of functions that you need to explore yourself. And here
real quick, what did the frac equals 1 do in the above example?
Oh, frac equal 1 means how many fractions you want to shuffle, I believe. For example, you just want to shuffle half of them, then the rest will remain the same. You just shuffle the first.
Okay, got it.
So one important technique you can do is really data frame. So in data science, probably the most important thing that you need to master is how to look at the API yourself. Right? So here you can see frac. Then it's a frac is fractional items to return. Oh, this is so maybe I understand it wrong. So this is how many items you want to return. Right. So for example, here, but I think 1 is not.
Yeah, so 1 would be
this is
all
a
of
fraction. Yeah, this is 100%, right? So for example, if this is shuffle and the return 100%. For example, if you can do something like this, right? So data, and then we can see how many rows are returned. Okay, so this is something like this. But you can also just return 1,000 rows, right? So then it's like random sampling. And then but anyway, so you can look at the API, just Google and look at it, you will understand everything.
Cool, thanks.
You're welcome. Yeah, so the important thing is telling you that you can pre-process the data into a data set which all have numbers here. So and once you have this is array-like, then you can use you can throw it into a machine learning model, like regressor. So regression and classification are different. Classification, you predict A, B, C, male, female. Okay, regression is predicting value. Let's say the temperature. Here we are. I think we are predicting predicting these rings. Okay, I don't know what it is. Maybe it's a it's an animal, right? So it's a sea animal. Okay. What's the file name? Yeah. How to read this? Abalone, right? So it's a sea animal, right? So this ring means how large it is. Okay, so based on the other features, right? So like weight, if it's very heavy, definitely could be a large ring. Okay, so yeah, so this is a column, right? So we want to predict right now. Okay, this is the column we want to predict. But now, because of the one-hot encoding, because of the get dummies, we have these here, right? So usually in machine learning, we want to put the y, the last column we want to predict. And this is a regression problem because this is a continuous number. It's not ABC, right? So what we can do is we can, for example, here we can switch the column, right? So here, for example, we can get the column IDs, okay? And then we can get the index of rings. Right? So the index of rings is probably where is this position, okay? Then it will return you, hey, this is 7th position. If you count, maybe 0, 1, 2, 3, 4, 5, 6, 7. Okay? And then what you can do is you can pop it. Pop it means it's pop out. And so this column is gone. Okay. And yeah, after popping, you can put it back. You can insert into the tail. Right. So this is popping it out, and then you insert this pop the column, which is pop here. You insert it back to the tail, okay, to the left. Then you have this. And next, what you need to do is in machine learning, we have training data and test data. Right? So we can randomly, because we already shuffled them, we get the 70% of the data. Right? So as a training data, and the rest as a test data, which is 30%. Okay? So in data frame, you need iLog to make the indexes rows. Okay, from the beginning of the row, if it's the beginning, you can omit it from the beginning of the row to a particular location, 70%. Okay, so if you just directly use the brackets, it will be the columns. It will be the columns. You need iLog to make row selection. So yeah, so these are the training data you fetch, and these are the let me see. What's the difference here? Oh, these are jobs. So the job index, because these index we don't want these index. If you drop, it will re-index to this. And then what we can do, we can also get test data. Test data is from the 70% position to the end. Okay, so keep in mind, this kind of boundary is not inclusive. Right? This is from 0 to n minus 1. Okay, this is from n to the n. Okay, so because the left hand side is inclusive. Okay, it's like 5 to 7. It means 5, 6 if it doesn't include 7. Right? So this is something like this. And then we have the test data also. So next, if you look at like here, right? So only this is not enough because we have the last column. Last column is y. So basically, we want something like this. Okay, so this is x, this is column y. Okay. Keep in mind, if you use the data frame and you don't use iLog, it's getting the columns, and this is -1, starting from the end. Okay. So we can isolate out the last column. Okay. So here's what we do. So all the rows, but the last column. Okay. All the rows. iLog means the rows go first and column. Okay. And this is basically everything, but not the last column. Right. So if keep in mind, this is including the excluding the last column. Okay. So the X trend is really everything here, and the Y trend is on the training, the testing on the testing. Okay. So finally, we'll get those training and testing data, and then you can call a model. Let's say here we are using a random forest regressor. If you don't know what it is, you don't worry about it. So you just say, hey, I want 10 trees in the random regressor. So and then you don't want to overfit, you give some max steps. Okay, and then this model is here, and then you fit it using the 70% data you just created with X trend, Y trend. After the model fits, the tree is built. Right, so there are 10 trees by the way. Okay, and then you do the prediction. Each tree will give you a value, right? And then ensemble model means that you will take the average of the model. Prediction to be done, final prediction. Okay, so let's run it. What is printed? This is why printed. So yeah, it doesn't matter. So y test is what we care about. Okay, so y test is the test values. You see, so x trend, y trend is what you give. Okay, so x trend, y trend, x test is what you give to the model, and it will give you the prediction of y test. Okay, so this is the y predict. These are the predict values. Okay? Because these model predictions are continuous, right? So it's a regression problem. You don't exactly get the integration, and this is the true values. Okay, it's the y test values. And you want these values to be close. Right? For example, this may be a little better because it's 9.3, this is 8. This is really bad. Right? This is 9.3, this is 14. This is really bad, not close. Right? And this is 9, and this is 10, this is close. Okay, so now you can use Numpy to compute some error. Actually, you don't need this even, because if you go to scikit-learn, there's a lot of ways to let me see. There's a lot of libraries that you can directly call to get those, scores. Right? So, like accuracy, you can directly get accuracy by calling this y prediction, y true, and mean square error, etc. It's a lot of things are actually here. Okay, but again, so because we are telling you how to write NumPy, so this is root mean square error. You can search for what it means. Okay. Basically, array difference between test and prediction. You take the difference and take square, and you sum them up, and you take square root. Okay, you take the average, of course, because there are so many rows. And that's pretty much, so this is saying that every prediction is around having an error around 2. Right? So this is from 9.3 to 14, it's more than 2. So this one is less than 2. Okay? It's 1.3. So on average, it's the error is around 2. If you have maybe 15 rings, it will guess from 13 to maybe 17. Okay, the model is not that accurate. Any questions so far? Yeah, so this is for regression. So we have also another model for classification, SVM support vector machine. But because of the time limit, I will leave it for you guys to explore. Okay, so yeah, so just go through these files that we shared, and you should get a good idea about at least the kicking start on data science. So because it's almost the end of the class. So yeah, so there's a student asking what's the difference between training and testing. So that's machine learning stuff, which is not quite close to us, but let me tell you briefly. Okay, so machine learning is supervised machine learning is something like this. You get X, right? You see a bunch of attributes. You guess Y, another attribute. Right? So like the ring number. Okay, so in training, you tell him when you see this, the ring is like this. Okay, this is the training data. Right. And when you give enough training data, next you give those attributes. You want it to be able to predict this ring. Okay, you don't give the ring. You give the model. Okay, the model gives you a y hat, right? And then you see the true, and you see what's the difference, right? And this is a validator model. In reality, if this model is really accurate, you don't need the y. Okay, you just want the model to see new data and produce y. Okay, so it's like a function fitter in supervised. Well, we will choose this parameter, maybe the tree shape or something. Okay. Do I answer your question?
Yes.
Oh, you're welcome. All right. So, any other questions? Because we will be ending here. Yeah. If you have no questions, then feel free to come to the office hour of TA and make a appointment with me. If you when you actually run these things, you encounter some issues. Okay. This has been pretty fast, so to spend some time working on them, and these things will always be useful. Okay, it's never wasting time to invest. It's like what I can say is like scikit-learn, like pandas. They are like Excel or Word, that's in Microsoft Office. Okay, so for data scientists, right? So these are basic stuff everyone should know. Okay, any other questions? If not, that will be end of this class, and we will start taking attendance from that. This video will be shared on YouTube. Okay, I will send the announcement when the video. Okay, thank you. Bye.
Thank you. Bye.
See you next week.
See you.